First Spin. Welcome to First Spin, a show where I learn how to use the Parallax Propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two experts.
I'm getting to be more of an expert over time as we have to answer all of your crazy questions, lady.
Yes.
It's because you're getting it by osmosis from me.
Well, osmosis through Roy, as Roy's having to look up the answers to some of it.
But perhaps I'm asking the same questions that you as an expert would ask as well.
No, we mostly just skim over the instructions and just get busy doing stuff. But
I see.
That's a secret.
Well, I like this comprehensive showdown here. So, we are continuing in our endeavors here to look at all the sensors that Parallax has to provide. And thus far, as always, we have looked at the ping sensor.
What are you going to do with all these sensors once you figure out how they all work individually? Are you going to create like some giant sensor array and send it to Mars or something?
That might be kind of fun, actually. Yeah, why not? We could do
Except
that.
you're not going
I just need the balloon.
because you don't. That's like really difficult.
I just need the balloon.
You know, hiring somebody with a rocket that could.
Roy, I don't want to hear your negative Nancy attitude. You need to have a little bit of that can-do spirit. We don't do these things because they're easy, but because they are hard.
Well, we will need quite a lot of donations from our listeners to have enough money.
If you guys want to donate like
$500,000
$500,000 for rocket fuel, I can get behind that. Well, maybe not behind the rocket. That would hurt. But
yeah,
you know what I meant.
It would be a little toasty down there behind the rocket.
You guys are silly. All right, focus.
Listener-funded space travel.
So
that's a great idea.
Focus.
Oh, sorry.
I'm trying to learn here.
Okay.
We've done the ping sensor, we've done the 5-position switch, we've done the servos, we have done the GPS module and the compass module. And today...
And the sensor and the servo.
I already said that.
Yeah,
you're repeating. Well, come on, expert, get on with it. So
sometime next year we'll have the list of sensors and things we've covered, and that'll take the whole show just to explain.
I think that sounds like a grand idea.
Sounds like a strange loop.
So today we are going to actually check out the passive infrared sensor, or the PIR sensor. Yeah. So motion detection.
Yep.
Have you gotten to play with it much?
I've played with it before in the past. I have one on my house alarm system, which I don't use because the cats set it off all the time.
I play with it, but more in the sense of like as kids, we had a game where you'd be riding your bicycles around at 3 a.m,
mm-hmm.
and turning on somebody's porch light was worth so many points, and their automatic light was worth another point value, etc.
You were one of those.
So we literally played with IR sensors before.
Well, today is your lucky day to turn on this sensor. So actually, I think this one's actually simpler than a lot of the modules. We probably could have covered it after the ping sensor, because it, like the ping sensor, only has 3 pins to it. Correct?
Works differently though.
True.
One of them's power and ground.
Right.
One of them's power, one of them's ground. So there's
right.
really only one signal pin.
Right, and the signal pin is labeled, I think, out. And this runs on 5 volts, I want to say.
Well, 3 to 6 volts.
3 to 6 volts, okay. So I just stuck it in the 5-volt port for my demo board, which I chose to use this week because my project's on my Prop PoE. But I wanted to see if we could go a little into how it works.
Well,
Kinda.
under the hood, it's pretty obvious how it works. I mean, it's
an infrared sensor.
It's got a filter on there that tries to keep out, some of the higher frequency stuff like UV and whatnot.
Okay.
And lets the lower frequency stuff like infrared light in.
Okay.
And then it probably has a little amplifier attached to a photosensitive element of some sort. I haven't really looked at the spec sheet on it to see what they used. But considering that it has a warm-up time of, how long did you say?
Well, according to the code, it looks like it's 20 to 40 seconds.
20 to 40 seconds.
Yeah.
There's obviously some sort of stabilization, probably temperature related, as it gets ready to keep track of what the average amount of IR coming into it is, and then if that amount that it's seeing changes by a certain threshold, then it actually fires off high down its pin, right?
It triggers the pin high for X number of seconds.
Okay. So when it detects IR or a change in IR, then
above a certain threshold,
then the pin goes on.
Right.
Or high.
And I'm sure it's constantly adjusting what that threshold is, over time. So as the sun comes up and down and whatever.
Right.
I guess that makes sense.
If it's basically detecting a rapid change. If there's a slow change in IR coming in, it won't count that.
Okay.
So
like
if
the
you
change
want to
in
fool
temperature,
you walk in very, very slowly to frame.
Yeah.
When I tried that, and it actually requires a lot less than just walking slowly.
Darn it, I was thinking about setting some of these up to keep you away from my cookies.
Yeah, not going to happen. I make your cookies.
Yeah,
anyway, so
once they're made, I want to defend them.
I see. So the other interesting thing about this is that you can also set the working distance. Do you have to set the working distance or you don't?
Well, it has a jumper, so it's just if you want it to detect a longer range or a shorter range. They just have two ranges. That's really all it is.
Okay.
And they're just reducing the sensitivity when they shorten the range.
Okay.
So that it will only work out to about 15 feet instead of 30 feet.
Okay. Yep. So I think on the board here, and I'm just taking a look at it right now, there's a side that says S for short. That's the 15 feet. And then there's a side that says L for long.
Right.
Now, there's a middle pin to it.
Well, that's just you're selecting, you're connecting the middle pin to either the right pin or the left pin, and that's connecting it.
Oh, I see.
Right.
I see. So it's like a
switch.
Floater.
It's creating a connection between the middle pin and one side or the middle pin and the other side, and that's setting.
So internally on the circuit, they're both working all the time. You're just picking which one you're connecting to the header.
So for those who get it packaged, and I didn't truly fully realize this, if you look at the actual sensor, near those S and L pins we were talking about, you'll see this little doohickey that you can take off and connect, and it connects two of the pins together.
Yeah, it's the jumper.
Oh, I was trying to put a wire, in there, and I wasn't sure what the middle one was for, but I was like, doesn't really matter. And I didn't know exactly what to connect it to, but that
the little doohickey that's on there is a jumper that shorts the two pins together. It's touching. Yeah.
I see. Oh, epiphany. Ding. Exciting. Okay, gotcha. All right. Okay, so cool. 15 to 30 feet, and the little jumper is included. And let's look at the KickStart code then, shall we?
Yeah. Well,
Okay.
for starters, just to explain a little bit, a couple of details. So when you put it into the longer range mode, it's a little bit more sensitive. So it might get more false triggers on things when it's in that range.
Okay.
It's depends on the environment you have it in, right?
Okay.
As to how much that will affect things.
Gotcha.
And
then,
of course, when you change the jumper, you're not actually changing anything distance-wise inside. You're essentially changing something to do with its sensitivity internally, right? It's
Right.
it's a really analog circuit at the end of the day.
Well, it's got a little microcontroller on there that's reading it, and the microcontroller is adjusting its algorithm based on the.
I imagine it's making it so that the threshold is lower for 40. But I mean, that's just a guess. I'm not the guy who designed the thing, so.
Yeah, there's probably a couple of factors involved. I don't really know the details of that code that's built into the little microcontroller on the board.
Mm-hmm.
So if you design this board, let us know how it works. We're curious.
And also, just in case anybody's curious about the field of view, like the cone shape that's around this, we actually haven't been able to find it documented anywhere, but I kind of tested it when I was messing around with the sensor, and it's pretty close to the full 180 degree 360 dome type of thing, but
Right.
it's
so
not
much higher
complete.
than Addie. She has like Coke bottle glasses.
Right, because I'm blind. Right. So
Yeah, so it's probably somewhere in the 160 or 150, somewhere
Mhm.
some wide cone that it can see,
Right.
and it's going to be based on that little dome is part of it that's
Right.
filtering and focusing the signal and whatnot.
Right.
And
as long as
just the
you're
fact that it's got a part sitting there on the board underneath that dome, and it can only see so much field of view.
right.
And one thing to note on these, it's passive, so that it doesn't have like a bank of IR LEDs or something flooding the area with infrared light that bounces off of things and then comes
Right.
back into the sensor.
Mhm.
It's just using the ambient light.
Right. But it does have an LED that it turns on when it triggers.
Right.
So you'll see it turn red or whatever
Right.
when it detects motion, and it
And-
stays on until it resets, which is like 10 seconds later. It resets itself. And
That is a red LED, not an infrared LED. So
right.
Right.
it's a good thing to note there that when that thing's on, it's not sending a reading. It means that it got a reading and it noticed that you were there.
Right.
Yeah. And like even my one for my alarm system does the same thing. It has a little red LED that comes on when it detects motion.
Gotcha. Cool.
So
It's probably easier to use anyway.
Next week, we'll be probably talking about something that you could hook to this so that when that little eyeball starts glowing red, you can also probably have it say, I'm sorry, I can't do that, Dave. And,
intruder alert, intruder alert. That's what I'd have mine say.
Danger, Will Robinson.
Danger. All right. So code time. We're going to go to learn.parallax.com/kickstart. And this code, so we're going to go through two different codes. One is this code and one is code that I made for it off of this code. With the main difference being which serial terminal code I used. So
Right.
the KickStart code uses the Parallax Serial Terminal, and with the Parallax Serial Terminal object, you end up having to use certain syntax, I guess.
A little bit different syntax.
Right.
And as we've learned, the BST serial terminal doesn't recognize all of the control codes that Parallax Serial Terminal does. So when you try to do the home function on PST, it just prints out a question mark in the BST serial terminal
Right. Right.
on
so
Mac.
right.
Which
So
is what you're,
right. So that's why when I looked at the code being run through my BST Brad Spin
Mhm.
tool, I saw a lot of question marks, and I don't know, formatting just didn't look right to me. But I imagine if you ran this through Prop Tool, it'd look proper.
right.
Yeah.
And it does, because I've done it and it looks just fine.
Okay. So we know, so object obviously is the Parallax Serial Terminal, as we've been stating. Constant section we know, variable section that's easy enough, just one variable state.
Mhm.
And then we start the PST, we warm up, or
Well,
have a
first
send a
we
string.
set the IO pin that we have the PIR connected to as an input.
Right,
Does that first, and then it starts the terminal.
right. And I actually had a question, mostly because this thing has 3 pins, I'm kind of comparing it to the ping sensor. Is there a reason that we didn't have to ping the PIR sensor to tell it to start like we had to ping the ping sensor?
It's always doing its thing.
Well, I can kind of explain. So with the ping, because the propeller or host microcontroller that's connected to it has to time the signal,
Mm-hmm.
it needs to know when this time, when it started. doing a measurement. So you're telling it start now and then counting. And then when it comes
Oh,
back
I see.
signal, you have the count, and that's how you determine how far it went.
I see.
With the PIR sensor, all it's doing is telling you, hey, there was motion.
Mm-hmm.
Right? So it just has the pin low, and then when there's motion, it sets the pin high.
I see.
And it leaves it high for a little while it, resets. Which that's one of the things with the PIR motion sensor is if you run out in front of it, it will trigger.
Mm-hmm.
But then if you stand there long enough, it won't reset itself back to off.
Right.
And then when you move again, it'll
set
trigger
it
again.
off. I see.
Right?
These are not the cookies you're looking for.
So in theory, if you were slow enough in your motion,
Mm-hmm.
which is really difficult for humans to do,
Mm-hmm.
depending on, it also kind of depends on how sensitive the PIR sensor is that
Thank goodness sloths don't like cookies.
But in theory, if you were slow enough, you could probably creep into view and creep out of view of the PIR sensor without it triggering, because like I said, it's based on a rapid change in temperature.
Mm-hmm.
Because if it were based on any change in temperature, it would constantly be triggering, because you're constantly, the warm up in the morning and cool down at night.
Mm-hmm.
And,
Mm-hmm. Mm-hmm.
on a cloudy day, it gets warmer and colder as the clouds cover the sun, and, your PIR sensor would be going nuts.
Right. That's a good point.
So anyway. Yeah.
Okay. So all we have to do then is set the pin to an input and to listen essentially to the PIR sensor.
Right. And just listen.
Right. And then we start the serial terminal. We send a string, quote, warming up. And then we wait 20 seconds,
right,
which is the PIR warm-up time. And I wasn't paying much attention when I first started running the PIR sensor, but I was like, why is this thing taking so long? And I was like, looking...
just because when you first apply power to the sensor, it's the whole circuit warms up, and that has an effect on the readings.
Right. Yeah. So then when I finally looked at the code... When I looked at the code, I was like, oh, it's clock freak times 20, not clock freak divided by 20. I'm used to like milliseconds.
Really short pauses.
Right,
yeah.
Exactly. So, okay, and then we clear the screen, and then we save the state of whatever the PIR sensor is sending, whether it's a 0 or a 1. 0 for no movement, 1 for movement. Then we pst.home, which moves the cursor to the upper left. And then the string will send in0 equals, and then we'll send the state.
Which is either going to be a 1 or a 0.
Right. And then it'll put a space mark, I believe. I think that's what that 1 stands for.
No, it's just saying 1 unit. The bin command from PST is saying show the 1 bit there.
Oh, okay.
A space is 32 for future reference.
Right.
Oh, I see. Okay.
In ASCII,
gotcha.
32 is a space.
Okay. So
and
send the
wait
result,
and
then wait a little bit, and then do it all over again.
And it just keeps repeating forever.
Right. So on the BST, like we were mentioning before, when I ran this, it would just say in 0 equals 0 equals, and it would just repeat that over and over again.
With a question mark, and then it went for really long all on one line.
Right, correct. And so I thought that was a little uglier than what I wanted it to look like.
Well, it's just because like I said earlier, it's the BST isn't working with the home functionality of PST. Right.
So I didn't know that, so I just decided to slightly rewrite the code in my own way. To make it look better. So like actually have it put an enter after the line. So with that, I changed the serial terminal object to FullDuplexSerial because I guess I've had more experience with it.
You might as well use it because the main difference between FullDuplexSerial and Parallax Serial Terminal is that Parallax Serial Terminal object uses a lot of the special characters that only really work with Parallax Serial Terminal, the program on Windows. Because you're not using that particular program, you might as well use
FullDuplexSerial.
FullDuplexSerial because you're just talking standard terminal,
Right.
which is just ASCII and the usual, 13 to enter and all that sort of thing.
Right. And so, and for me, it was mostly that I noticed that most of my other code has used mostly FullDuplexSerial.
You're normally talking to like physical objects that speak serial.
Right. So that's what I just chose. So if and we'll put links, of course, to this code. Now,
didn't you like do a huge blog post on like the reasonings behind why you liked the full duplex serial?
I just did a blog post on the differences.
Okay, so you just like
between
went
the
through
syntax,
all of
like the easy stuff, like starting the terminal, making a sending a decimal versus sending a string, versus sending both, like both a string and like say an ASCII bit byte.
It's all ASCII
thing.
Really at the end of the day.
Yeah. So that was what that one blog post was about.
Byte by byte.
Yeah. And I noticed that I miscommented
so you'll
on
put
my
a
code.
link to that in the description, I assume.
Yes, of course. Yep.
Mm-hmm.
So the main difference here is I changed the baud rate to 9600. I just wanted it to go a little slower so I could see what was going on.
Mm-hmm.
Kept the wait count to let the PIR warm up. And then I think I took out, what did I take out? I took out the PST clear screen.
Right, because that's not an option in full duplex serial. Doesn't have clear or home or any of those special commands for the serial terminal.
Right. So it didn't really matter to me that whether or not anything was cleared or not anyway, so I didn't bother like replacing it with whatever
and with your BST terminal, it would just print out a question mark anyway because it doesn't recognize that clear command.
Okay. Well, that works.
Right.
Yep. So then we repeat the state. We still the global variable state we still set.
Right.
And then to move the cursor to the upper left, I think instead of
you did a TX1
PST home. Yeah, I
right, but the problem is that still doesn't work with the BST terminal. It does if the PST TX1 is just the same thing as doing PST home when you're working with Parallax Serial Terminal instead of full duplex serial.
Mm-hmm.
So you could have left that line out with your particular program because you changed it to just print it out and go to the next line, so you would see it scrolling by instead of up at the top corner all the time.
I see. Okay.
And that's why you were seeing the question marks in there that you mentioned in your blog post.
Okay. All right.
Mm-hmm.
So had I been on Prop Tool with Parallax Serial Terminal, then this would have worked. Otherwise, PST string I send instead of in O, in 0, because that didn't make much sense to me. I just put the state.
Right. They just were saying in 0 meaning the input pin 0.
I see.
Right.
Yeah. That to me is too technical.
That's fine.
Give me what
I probably would have used state just like you did.
Huzzah! Doing it like the experts do. And then send the decimal, and then send a carriage return 13. And then wait. So really not too many changes, just syntax changes, because I'm more comfortable with using ASCII in this manner. Just saying pst.tx, blah.
Right, the full duplex.
You're like getting right down there to how it really works.
And well, that's instead of saying thing. Like pst.happy-go-lucky time, I mean, like, what does happy-go-lucky time mean? It could be 1332.
You got to take the time to go in there and dissect
whatever.
What it's actually doing and make sure it's not going to harsh on anything that you're handing it. And
right.
I just like going right to the source. The raw bytes.
Right. So that's easy enough.
So I'm right there with you, Addie.
Thank you. And I think that's it.
Cool.
Is that it? Is that right? Pretty simple.
Yeah, it's not a complicated little gadget. I mean,
yeah, pretty simple.
It's you set it up, you give it power, and it tells you when stuff moves.
Yeah.
After that, it's up to your code to glue it to other stuff.
Right.
So yeah, pretty handy little thing.
And I'm getting more comfortable.
One
with Serial
application
Terminal.
that comes to mind for me with it is hooking it up to a camera to have the camera take pictures outside when animals wander around in our backyard.
They do have
Yeah,
those, don't they?
You could build one yourself with that pretty easily.
As long as the bears don't gnaw in it.
Yeah.
I think they've shown documentaries where the bears like gnaw in the cameras and such. Awkward.
I would not want my DSLR to be
No.
gnawed.
So you just mount it up way up high out of sight and view.
No.
Yeah.
Yeah. Put the sensor outside. Put the camera in a window.
Yeah. That'd be cool.
So it's been a sort of fun week. We've had a lot of feedback on something we did.
Yes.
So we took this epic road trip out to Parallax headquarters for the expo, the robotics expo this year. And while we were there, we actually had an opportunity to sit down with Chip, the guy who designed the propeller, and his brother Ken, who sort of handles the business side of Parallax.
Mm-hmm.
So Chip and Ken Gracie, they sat down with us right in the middle of the expo.
It was a
and
very busy time too.
we did a half-hour long interview with them.
Yep.
And not about the usual, there's some of the usual like technical details in the Prop 2 and spoilers and stuff like that. But a lot of it is actually more like them talking about what got them interested in engineering and electronics and machining and some stories of when they were kids, because they're brothers. They got lots of funny stories about each other.
Mm-hmm.
And Chip is the older brother by a couple of years.
Yeah, we
that slightly
uncovered
surprised
that.
me.
I think it's a scoop.
That slightly surprised me, although I think it's because I was biased by Ken's height.
Yeah.
Yeah.
Ken is much taller, but
Right.
Chip is the older brother.
Right. And actually, some folks didn't even know that they were brothers. So now you know.
Yeah.
So we know a lot of you guys couldn't make it out to the expo because we're spread all over the planet.
Right.
And even if you did make it to the expo, man, oh man, were those guys busy
Yeah. They
over
were
the
running
weekend. And
around.
I'm sure a lot of people that would have liked to sit down and talk to them just simply didn't get an opportunity to.
Right.
And we were lucky enough too, and we had all of our cameras going, so we edited it together and we put it up on YouTube so that all of you guys could see that as well.
Mm-hmm.
So we're going to add a link to that in the description for this episode on the website firstspin.tv.
Correct. And I think in weeks to come, we still have the gyroscope and the altimeter module.
Yeah, so we have a super secret one that we're going to be doing too, but we're not allowed to say
yes.
anything until
Yeah.
it's
That is
actually
correct.
up and available for sale. We've had it for 5-6 months, and we've been playing with it, and it's a really, really cool toy that they're going to be selling.
Super secret grand idea.
Yeah,
Yeah.
I thought it was a great, grand idea. Yeah. So, definitely make sure that you pay attention to the first spins in the next couple of weeks, because I don't know which week it's going up. Might be next week. Might be the
Maybe
next.
week after?
Don't know. And yeah, when it does, it's going to be really, really fun. We're going to have a fun episode.
And as always, if you guys have any questions about any of the things that we go over, please do not hesitate to ask. We love answering questions. We love hearing from you guys. Comments, questions, snide remarks, we'll take them all in stride. And yeah.
Yeah, we even talk about them on the show sometimes.
It's true. It is
Yeah.
true.
Mostly just the snide ones, though.
That's okay. They're the fun ones, though.
Yeah.
I mean, the
All
good
right.
ones are fun, too.
Well, that's all that we have time for this week. Like I said, you guys can find the show every Tuesday at firstspin.tv. And you can get us on Twitter at TYMKRS. And yeah, I think that's it for now. We'll be back next week with more.
Okay. Bye.
Bye.
See ya.